So in this part, let's talk about the grid plug and play profile and what's the role of the grid plug and play daemon. First, let's understand that the grid plug and play profile is actually a small XML file which is located in grid home GPnP hostname profiles peer, and the name of the file is also fixed, that is profile.xml. It is used to establish the correct global personality of a node. Each node maintains a local copy of this profile and is maintained by the daemon GPnPD. So let's go and have a look at the profile. So I am going to grid home GPnP hostname profile peer, and the name of the file is profile.xml. This is the file. It's a XML file which contains the cluster name, the signature, the cluster's universal ID, the public and the private net mask along with the interface names, and more importantly, it stores in the highlighted section the location of your cluster file voting disk. So it simply tells me that the CSS voting disk location is onto ASM. In the absence of profile.xml, there would have been otherwise no way to know where is my voting disk. We'll also try to understand in the startup chronology where the GPnPD daemon fits, and it also records the location of the SP file of your ASM instance. So ASM instance SP file itself is on ASM, which is quite interesting. Means to start an ASM, I need to read parameter file, and to read the parameter file, it is on ASM disk group. So doesn't it become like a wild chase? Reading ASM SP file requires ASM to be up and running, and to make it up and running, I need to read the SP file. That's where the grid plug and play daemon plays a very important role. A similar file in SA beta would also be there, and it is in sync with this particular profile. Very important this thing is, it is protected by a signature called as valet. A valet is one that stores certificates and signatures. So you can't directly edit this file and say change something to something else. It will be regarded as a corrupted profile because it's protected by a valet, a signature. That signature has to be generated again if I want to go and modify something without I consulting the valet. So I cannot directly go and edit into this file. So very important. What it stores? It stores the global personality of a node. What is the public? What is the cluster name? What is the cluster UID? Where is my SP file? Where is my voting disk? Which is my public interface? What is the net mask? Which is my private interconnect? What is the net mask? And also, what is the ASM disk location? The disk string, like init or a parameter of your ASM, the disk string is also stored. GPnP profile is used to store necessary information required for the startup of Oracle clusterware, like SP file location, ASM disk string location, etc. It contains various attributes defining the node's personality, such as cluster name, network classification, like which NIC with which net mask is public, which other NIC with other net mask is a private interconnect or cluster interconnect. Where is my CSS stored? CSS is nothing but the voting disk. Where is my voting disk stored? The location is also documented into the GPnP profile. Storage to be used for ASM, that is the SP file location, and in which location ASM disk group disks are to be located, the disk string, and more importantly, the digital signature. The profile is security sensitive. It might identify the storage to be used as a root partition of a machine. Hence, it contains a digital signature information of the provisioning authority. Now, consider the case that anybody would have been free to edit it. In this case, somebody goes here to this particular section of Oracle CSS profile and says ID is equal to CSS, discovery string equal to slash as in root. So what will happen? So there is every chance that I might overwrite the boot sector or the booting related files of my operating system. So that's why it does not allow you to directly go and edit the file manually. That's why it is protected by a wallet, a signature. Until that matches, nobody is allowed to go and just modify this file. The wallets themselves are kept in the location wallets. So I am in grid home, node name, wallets, and those who have worked against those wallets, you must know that the file name is typically cwallet.sso and ewallet.p12 are the namely the certificate or digital signatures. So you can't go and directly modify the file because it is protected by the signature. Now question is then, if it comes to modifying this file, how should one modify? That's a different thing. But I want to check which is my current profile in use. As a root user, you need to type the command GPnP tool get. It will print me the same profile. See here, it has printed me the contents of profile.xml for this particular node. The actual command that it ran internally was gpnp tool.bin get -o-. That -o- is to print the output on the standard output device, which is my screen. That's why it has printed me everything, and at the end it says the success status. So it was able to successfully retrieve the profile from the XML file. GPnP daemon replicates the changes across all the nodes, and the profiles are periodically updated whenever you do the installation, whenever your system reboots, or whenever any of the configuration related to what goes in the profile gets changed. So if I change the nick, if I change the purpose of the nick, if I change the net mask of the nick, if I change my voting disk location from ASM to elsewhere, if any of these identities related to cluster changes, automatically the profile.xml file used by GPnP would also change. Profile is updated whenever changes are made to the clusterware with the configuration tools such as OIFCFG, which is used to change the network identity or the network configuration, CRSCTL to change the location of your voting disk, or ASM CMD if you change the ASM disk string or SP file location. Now all these changes are stored in your grid plug and play profile file. To start clusterware, this is very interesting. To start the Oracle clusterware, voting disk needs to be accessed. And where is my voting disk? It's onto ASM. Is my ASM up and running by now? No. So I need to start ASM. But where is the SP file of ASM? It's again onto the ASM. So isn't it very confusing? Like, to access voting disk to be part of a cluster, I need to start ASM. And to start ASM, I need a SP file. And the SP file itself is onto ASM disk group. Then how does this whole thing works? To start the clusterware, voting disk needs to be accessed. If voting disk is on ASM, this information that the voting disk is on ASM is read from grid plug and play profile. The syntax that I highlighted called as CSS-profile equal to CSS, discovery string equal to plus ASM. This tells your Oracle clusterware OHSD that my voting disk itself is on to ASM. Okay, that was one part of it. The most important part of it is the voting disk is read using the internal utility called as kfed, even if ASM is not up and running. So Oracle has an internal way to access the data on a ASM disk group, and that is to use the kfed utility. the kfed utility on a given disk can act upon and can print you metadata and the data from it. So it can read a particular disk directly even when my ASM is not up and running, and it will help you read, not you but the actual programs can actually read the data using the kfed utility. Without any knowledge, I would suggest do not use kfed utility, because it's like directly tampering with the, although it helps you to read it, reading is fine, but you should not use any other utility to go and edit these data values. So don't change it. Kfed wise you can always obtain it and read it. I would try to apply kfed using lscsi command. First I want to see which are my disks. This is my first ASM disk. How do I know? I said etc init.d oracle ASM list disks. So it says I have ASM disk 1, 2, 3 and 4. Where is typically your voting disk kept? Voting disk is always onto the first disk of the first disk group that you created during installation. How do I know? I go to U02 grid, bin, CRSCTL, query CSS vote disk. It says your vote disk is on where? ASM disk 1. Now ASM disk 1 itself is a ASM lib implementation. So itself it's not a disk. It's actually ASM disk as an alias created for some LUN block device. I don't know out of SDB, SDC, SDD and SD which is the one which maps to this one. Easier way to find out is by saying SDB to E. Now why I have not included A? Because A seems to be a local disk. I am only worried about shared disk, LUNs, and my LUNs are numbered from SDB to SDE. And then I say dev Oracle ASM disks star, and then I look at, I mentioned etc, it should have been dev, and then I look at the major and the minor device IDs to find out which is my actual block device which corresponds to ASM disk 1. So I am checking what is ASM disk 1. It's 18,17. The major device category is 8, which means SCSI devices, hard disk, and the minor device ID for that particular disk is 17. Now I want to check where does it matches to the actual block devices present to me by my operating system. I came to know from here. So the actual block device is SDB1, which is present to my ASM by ASM lib as a ASM disk 1, because their major and minor device numbers are respectively 8 and 17. Now I can use the kfed utility against this device to print me the metadata. Now it says you have to type in some extra parameters to use this one. But this is the way one could have accessed a specific metadata element using a kfed utility against a certain disk. This is how it comes to know. Now understand what is stored in profile. Profile stores where is my voting disk. So it says CSSD profile CSS equal to plus ASM discovery string equal to plus ASM. So I know location of my voting disk is on ASM. Now which disk to scan from the ASM, that is given into the disk string parameter in the profile. So if I check the profile here, from this particular flag I came to know that my voting disk is on ASM. And then where are my actual ASM disks? That I come to know from this section. See here the discovery string is as empty. Empty means it's like ORCL colon star. If I would have seen this string on AIX, it would have shown me something like /dev/rh disk star. Means go to the dev directory and check all the disk devices with the name rh disk. Read their headers and then find out which is the disk which contains the voting disk. So it's nothing but at ASM startup time, ASM instance scans for the metadata available on the disk, and this is when it will come across a device named dev sdb1 that is where it will find a device, your voting disk, and for that matter the SP file also. So it's the metadata knowledge that Oracle has built into the program name kfed, and it can read that data from kfed utility. But for us, when I typed it without any knowledge, it says tell me what exactly is that you are looking for. These are the flags. So it says tell me what exactly you are trying to see through that particular kfed utility. In short, the point that I want to come back to is the voting disk is read using kfed utility even if ASM is not up and running. Otherwise it would have been a never ending chase. To start ASM, I need to read SP file, and SP file itself is onto the ASM disk group. So it would have been a never ending chase otherwise. The clusterware checks if all the nodes have the updated grid plug and play profile, and the node joins the cluster based on the GPnP configuration. Whenever a node is started or added to the clusterware software on the starting node starts a GPnP agent. If the node is already part of the clusterware, the GPnP agent reads the existing profile on that node. If the node is being added to the cluster, the GPnP agent locates the agent on another existing node using the multicast protocol provided by MDNSD, multicast DNS, and gets the profile from the agent on one of the existing node. So when a new node is being added, I don't know if it is, there's already existing node. So on my node which is being added, it automatically starts multicast DNS daemon. It broadcasts the message. I told you earlier what is the purpose of MDNSD. It is used in case of GNS implementation and also to obtain GPnP profiles from existing nodes. So the agent on the new node to be added using the multicast DNS sends a broadcast request, multicast request to everyone. From any of the existing node, the agent running there responds back saying, here is the profile, use this one to join the cluster. Next, CRSD needs to read the Oracle cluster registry to start up various resources on the node and hence update it as a status of a resource changes. Since OCR is also stored on ASM, location of ASM SP file should be known. And that's why SP file is also documented into the grid plug and play. But OCR is not documented because OCR is not read directly. First the ASM instance starts, the disk groups are made available, then the OCR can be read from that particular ASM disk group. The order of searching the ASM SP file is first check in the grid plug and play, is there a ASM SP file located? If not, then check in the grid home DBS SP file plus ASM1.ora. If not, then check the default configuration file, that is init plus ASM1.ora. So check first in grid plug and play. If not found, then go to the grid home, check for the SP file. If not found, then check for the P file of your ASM instance. If you want to see how to get the grid plug and play to display the ASM parameter file, you can use the parameter get pval. Now those who are not familiar with this one, I am going to U02 grid bin. I don't know how to type it, so I said GPnP tool -h. So it prints me the help of the grid plug and play tool, out of which I am using which parameter, get pval as an attribute, and then I need to tell which is the, that pval is nothing but the parameter value. So I am saying grid plug and play get pval -h. So it is unable to locate, or simply saying help, it still cannot locate the help of that parameter, which means it's not very properly documented, because Oracle does not want you to use this without any proper knowledge of this thing. But assuming from some of the documentation, I have found out that the get pval has one parameter called as -ASM_SPF, or I could have typed it directly here itself, help. These are the parameters, and one such parameter you would see here is ASM SPF. Clear? So this is the complete help of your GPnP tool. Well, now I am using it. GPnP tool, get pval, the parameter itself is SPF, and if I don't mention -p, it will assume that the profile file is present in my current working directory. So it says, well, I am not able to locate your profile file. So you can mention the complete path of your profile file by saying U02 grid GPnP SA alpha profile peer profile.xml, and since I want the output to be displayed on my standard output device, use -o-. See here, what is the output? It tells me where is my SP file. So it says your SP file is in data, this group name data, group 02, ASM parameter file, registry.some number. So that is the role of grid plug and play. So assume a case that there is no grid plug and play. Obviously you won't be able to start up the cluster where, because it is from here it comes to know where are the other artifacts stored, and then it follows the chronology of the startup of various daemons. So that was about grid plug and play. Now understand the log and trace file locations for your grid infrastructure. Within the grid home, you have log as one of the top level folder, and then you have diag and CRS, out of which the most important one is the node name folder. So I am going to U02 grid log, and I can see CRS, diag and node name. When I go to the node specific grid daemon logs, for each of those daemons you would see a separate folder created. So there is a folder called as client, CRF logd, CRF mond, CRSD, CSSD, CTSSD, CVU, which is a cluster verification, disk check utility, diskmon, EVMD, GIPCD, GNSD, GPNPD, MDNSD, OHSD, RACG, SRVM. For each of those daemons there is a separate folder created in it. Well, it's not for the daemons also, there are extras as well. That is client. Now there is no daemon named as client. There is also a client folder. So understand this, the top level architecture within the node name. You will see OHSD, CRSD, CSSD, UVMD, agent, GPNPD, GNSD, client, GIPCD, diskmon, SRVM, admin, CTSSD, MDNSD, RACG. Apart from that, there is also client, and most important to it, there is a file called as alert node name.log. This is like the alert log, the primary diagnostics location. So the very first file after a node reboot, if the cluster services do not start up, the very first file to check is alert node name.log, and it will then tell you what is the problem, what is that it was trying to do. Probably it will then redirect you to a specific daemon saying I was not able to start because I was unable to locate voting disk. And why I was unable to locate voting disk? Because CSSD daemon said so. So then you go to CSSD daemons log file and try to find out why it was unable to find voting disk. Probably the disks are not visible, LUNs. Probably those disks are corrupted, they are missing. That's why the clusterware was not able to start. So one after the other, you need to start chasing the daemons, provided you know what daemon is being used for what purpose. Now within agent, remember we talked about two agents. One is Aura agent and one is Aura root agent. Those are either triggered by OHSD or are triggered by CRSD. So those agent related files for the Aura and Aura root agent triggered by OHSD will be under OHSD subfolder. And for the daemons Aura root agent and Aura agent triggered via CRSD, they will be under CRSD folder. So you should know what are those agents supposed to do. So if your VIPs are not attaching, if your scan IPs are not attaching, you must know where to go and check. It's the job of a root agent. Now which root agent? Of a CRSD agent, of a CRSD daemon. So I should go and check why CRSD daemons Aura root agent underscore root, or what information, diagnostics information it is showing. RAC is a call out. custom written scripts I told you to trap a event thrown by EVMD. I am trapping it and I may take a corrective action called as user callouts, so that I can check the log with respect to the customization into RACG. Apart from that, there is ACFS-SEC. These are all new in 11.2020. Remember I told you 11.2020 comes with a built-in cluster monitor, that is the cluster health monitor. So these folders primarily are the members of that cluster health monitor tool, logger and monitors. That CRF is nothing but that cluster health monitor tool. Earlier the same tool was known with the name as IPDOS. Now it has been renamed as CHM, which is the cluster health monitor. So that is the location of your log and trace files. So if your node is unable to join a cluster, you should check the log of alert log, OHASD, and then CSSD. Because whenever the services start, the first entry point is alert node name dot log. The next immediate service that takes control is OHASD. Then OHASD triggers CSSD agent. CSSD agent then triggers aura.cssd. CSSD is the one who is responsible for joining the node in a cluster for heartbeat. So you should check when a node does not or is unable to successfully join a cluster configuration, then you should check CSSD. But if any of the resources are unable to start, like I am unable to start a specific instance, in your case it was showing an error as remote underscore listener parameter is invalid. Who is responsible for starting the cluster application resources? CRSD. But CRSD is not a workhorse on its own. It just spawns supervisory processes, Aura root agent and Aura agent. So depending upon which resource is not starting, you should chase the agent of CRSD daemon and find out which particular daemon is or which particular cluster application resource is unable to start. So if I see that scan IPs are not attached, then its scan IP is also a cluster resource. CRSD is responsible. Since it's an elevated privilege activity, it will be done by Aura root agent. Then I should chase grid home, log, node name, agent, CRSD, Aura root agent underscore root. If it's an unprivileged activity, like starting up a database instance, it has errored out. I don't know why my instance is not starting. The region should be located here in Aura agent underscore Oracle, because CRSD is the one that is responsible for bringing up the cluster application resources. Now to be able to reach to that level, first who comes in picture? GPnPD. So somebody says, no, my ASM itself is not starting. The first thing you should check is alert, OHASD and grid plug and play. Probably grid plug and play was not able to locate the profile. Since it is unable to locate a profile, it does not know where is your SP file. It does not know where is your voting disk. So that's why it was not able to start up your ASM. But starting up of ASM is the job of whom? CRSD. So if GPnPD level everything was okay, it was able to locate a profile, then certainly the problem is at a CRSD level. CRSD has Aura root agent and Aura agent. Since starting up of an ASM is not a privileged activity, you should go and check Aura agent. So you have to drill down through that chart to find out where is the diagnostics area, where are those diagnostics log available. Now who can do this? One who has understood the startup sequence on slide number 1 can do a better justice on troubleshooting where to look for a log. Otherwise, there are several locations where logs are available. And manually asking a DBA to go and read each and every log, it's even more torturous. Saying, take a guess, take a pot shot, see where my log is. So don't keep him guessing, it's not a guesswork. You can directly pinpoint an area where the problem could be, provided you understand the startup sequence starting from init and below for the 11G release to grid infrastructure services. So if a particular resource is not starting, there is a proper way to chase it. So all other services were started. ASM is up and running, scan listeners, VIPs, scan VIPs, uh, ASM instance, but my database instance is not running. Somehow my database instance never came up. Is there any point checking alert log? No point. Is there any point checking CSSD? Because my node was able to join a cluster. Is there any point checking GPnPD? Grid plug and play? There is no point doing a grid plug and play. Is there any point looking into GIPCD? GIPCD only takes care of interconnect related HAIP. So there is no point checking GIPCD. Though I should be able to pinpoint, oh, I need to look into CRSD. And within CRSD, I need to look into Aura agent. That what is that log showing that why it was unable to start up a given instance. So you don't have to necessarily check all the logs for all the troubleshooting. But if somebody says, one of my private interconnect path ETH1 has failed and then my cluster split. So it was not able to pick up the redundant path. So it should have actually relocated your HAIP from that first private interconnect to the second private interconnect. If I am using a HAIP feature, that is a redundant interconnect feature. If I am unable to see that the switch has happened, is there any point doing alert log? Grid plug and play? Is there any point looking into GPnPD, multicast DNS daemon, GNSD? Nothing. I should be able to pinpoint where. So I should directly go and check GIPCD. Because GIPCD is the one that is responsible for redundancy at an interconnect level. OLR is one of the substantial components added into 11G release 2. Stands for Oracle Local Registry. OLR was added in 11G R2, which is a local registry for node specific resources. So until then, 11G R1, there used to be only one file, Oracle Cluster Registry. There was no concept of OLR. All the cluster application resources were registered in OCR until 11G R1. Starting from 11G R2, Oracle has created two separate binary files. Node specific resources are registered in OLR and cluster resources are registered in OCR. OLR, unlike OCR, is not shared by other nodes in the cluster. So the location of OLR will always be specific to a given node. How do I know? Here I go. I said cat /etc/oracle/olr.loc. So it says here is your OLR on alpha. Now I know for sure U02 is not a shared location. It's a node specific non-shared disk. So my OLR is not on a shared disk. What is the another way to know? I can go to U02 grid bin and then I can say OCR config -local. No, not OCR config, OCR check -local. So I said OCR check -local. Local is for OLR. If I don't mention local, that means the command will be applicable for OCR. So it says yes, this is the location where your OLR is. The OCR checks command also checks for the integrity and logical corruptions, if any, into the OLR. As of now, there is neither an integrity loss, there is neither a logical corruption into my OLR. So these are the two ways to find out where your OLR is. So certainly it's in a non-shared location. That's what I said here. OLR is not shared by other nodes in the cluster. So if I'm talking about a 10 node cluster, how many genuine OCR copies will be there? One. Other may be replicas or mirror copies of it. You can maintain up to 5 OCRs, Oracle Cluster Registries. But how many OLRs will be there in a 10 node cluster? 10, because it's node specific. It is the very first file that is accessed to startup clusterware when OCR is stored on ASM. When OCR is stored on ASM, so all my cluster information, all cluster application resources are registered in OCR. OCR I cannot access until ASM is started. ASM disk groups needs to be mounted to be able to access OCR. So how does this happens then? So local services are read from OLR, and that is how it manages to start it. Now why Oracle made this drastic change? This was made to promote use of ASM so that you can keep your voting disk and OCR on ASM. Up to 11GR1, your Oracle cluster registry and your voting disk, because of the design limitation, couldn't be kept onto ASM. So they had to be either on a shared file system, CFS, cluster file system, or NFS mount point, or at the max it could have been on a raw device. Preferable location was raw devices, which is a shared raw device across machines. But to facilitate the movement of OCR and voting disk onto ASM, and because of the design limitation, they couldn't put it, so they added a new component to 11GR2, that is the Oracle local registry. So certain resources which are very node specific are written into OLR, and then when I power on a machine, init triggers OHSD, OHSD triggers all other daemons, and then it reads OLR. OLR starts up the services on the local node. One of the services is grid plug and play. Grid plug and play reads the profile. It starts the service called as ASM. ASM mounts the disk group. Once the disk group is mounted, I can read the OCR. But to read voting disk and SP file, ASM need not be mounted because the whole information can be read internally using the kfed utility by Oracle. So OCR should be accessible to find out the resources which needs to be started on a given node. If OCR is on ASM, it can't be read until ASM, which itself is a resource for the node, and this information is stored in the OCR itself, is up. So to start ASM, I have to read OCR, and to read OCR, I need to start ASM. It would have been a catch-22 situation otherwise. To resolve this problem, information about the resources which need to be started on a node is stored in an operating system file, which is called as the Oracle local registry, or OLR. Since OLR is a file, an operating system file, it can be accessed by various processes on the node for read and write purpose, irrespective of the status of clusterware. So I need not have my grid infrastructure clusterware up and running. I can directly access it by some program since it's a file present at the operating system level. That's why I said it can't be kept on ASM. Remember the placement component placement discussion, the Excel sheet? OLR can't be stored onto ASM. Hence, when a node joins a cluster, OLR on that node is read. Various resources including ASM are started on that node, and once ASM is up, OCR becomes accessible. If OLR is missing or corrupted, then obviously clusterware on that node cannot be started, because this is the first file that is read to determine which are the local resources to be started, and one local resource to be started is the ASM instance running on that machine. And where is the SP file? That is read from grid plug and play. Accordingly, the SP file is read, the background processes are started, memory is allocated, ASM instance goes from no mount to mount, disk headers are scanned, the necessary disk groups are mounted, and this is how it accesses the Oracle cluster registry. So very important. The OLR file is located by default under grid home, cdata, hostname.olr, and that's what we have seen here. Grid home, cdata, nodename.olr. The location of OLR is stored in the OLR pointer file etc oracle olr.loc, and this is used by whom? OHSD. So OHSD needs to know where is my OLR. And like an inventory pointer file which is etc orinst.loc, which points to your central inventory, there is a pointer file for OLR as well as for OCR. OCR also has a similar pointer file. So I check from the pointer file where is my OLR. Similar way, there is a pointer file called as ocr.loc. It points to my OCR, and see here the difference. OCR is on a ASM disk group named data, whereas OLR is purely a file at a file system level. What information does OLR stores? It stores the version of your Oracle clusterware, the clusterware configuration, configuration of various resources which you need to start on that particular node, everything is automatically registered into the OLR. Now given the fact that if my OLR is missing, I cannot even start up my cluster, it means it's a good idea to take a periodic backup of it. To take a manual backup of OLR, you can run the command ocr config -local -manual backup. Before I do that, I said u02 grid bin ocr config -local -show backup. There is already one backup that has been taken automatically, and my backup is on SA Alpha, dated 12th of January 2013, or I don't know, 1st of December 2013 rather, at 1627. The location of my file is here. So I am checking it now. This is my file. And which is my original file? This is my original file. So this is the current copy of OLR. This was the one that was backed up on 1st December 2013. This is my backup copy. So if my original copy is lost, I can always restore my backup copy. OCR check -local will show you the location and will also perform the integrity and logical corruption check. Remember, who has access to this file? Only root user. So if you want to run OCR check command for your local option OLR, you cannot run it as Oracle user. See what happens. Operating system error, permission denied, because who am I typing this command as? Oracle. But I know that my local copy of OLR is only readable as a root user. But if I do the same thing here, it has absolutely no problem doing that. Clear? You can use OCR dump -local -std out to find out what is generally stored in the OCR or OLR. Command is same: OCR config, OCR check, OCR dump. But the command can either be used for OCR or OLR. If you use -local in the command, that means you want to do it for OLR. If you skip that, that means you want to do it for Oracle Cluster Registry. So I am checking OCR dump -local. That means I want to generate output of OLR. STD out. That means show me on the screen. God knows what it is. Clear? Not readable, not very well formatted. Well, nothing to worry about. Instead of std, you can say xml/tmp/olr.xml. So I said this time generate that file's output instead of this garbled output. Generate it in an XML format so that at least using the color code tags in your Internet Explorer, you can distinguish what tag is what. So I can see there is system.crs, whatnot, user security, who owns this thing, root. What is the Aura CRS home, grid home. What is the version? What is the active version written in your OCR? Who owns the grid plug and play, Oracle O install? And then the signature, valid. So too many things into the OLR also for that matter. And at the end you will see there are local resources, which is a cluster interconnect, HAIP. about OHSD. About ASM instances. See here. So these are those local resources that are stored in your OLR. So you can dump it by saying OCR dump hyphen local hyphen std out, but it gives you a textual output which may not be very readable. You can ask it to dump it in a XML format. You can also perform a logical backup of OLR by saying OCR config hyphen local hyphen export and the name of the dump file. I said OCR config hyphen local hyphen export name of my file. If I check what type of a file is this one, it's a binary file. So better not edit it. If I open this thing, so it looks like a foreign language class. Now from this exported dump, you can also import it back at some other point in time by saying OCR config hyphen local hyphen import and give the name of the export dump file that you have taken a backup of. Remember, this is like a export import of database, logical backup. And then manual backup is for a physical backup. So manual backup is actually restored and logical backup is actually imported. So if you see, opposite to manual backup is the restore and opposite to export is import. For some reason, if you experience that it is corrupted, you can also request Oracle to repair it by saying OCR config hyphen local hyphen repair OLR and followed by the file name. You can also take a backup file location by mentioning you can change the location of the backup by mentioning backup LOC equal to new location. By default, my backup is going under C data. If I want the backup should go elsewhere, you can also change the location of that OLR backup. Assume that I lost my OLR. What would be the steps to restore the OLR? To restore OLR in case of loss, you can follow the below process. Stop the cluster services on the current node by saying CRS-CTL stop CRS. This cannot be done by a regular user. It has to be done as root. Then say OCR config hyphen local hyphen restore and provide the file name of physical backup that you have performed. So restore that from the backup. Now if for some reason the above command fails, then try doing this manual fix. Change to the OLR location wherever it is supposed to be. Touch the file with the name as hostname.olr. Change the file permission to 600. I have already shown you. The file was having only read write for the owner. And change the ownership to grid o install of that particular file. Grid means any user who has installed the grid infrastructure software along with the group. And then try doing the restoration. And then retry the restore command, which is OCR config hyphen local hyphen restore physical backup file that you have taken a manual backup using. Once it has been successfully restored, you can now check OCR check hyphen local. Then you say CRS-CTL start CRS, and just to be sure, you can run cluster verify component OLR. Obviously, this as a regular user. So I am running the cluster verification utility to check my OLR. If everything is okay, it will report it as successful. So it says verifying OLR integrity, checking OLR config file, OLR files is successful. everything was successful. It says there was a warning. The check does not verify the integrity of OLR. To do so, run this command as a privileged user, because the file itself is owned by root. Next one is the Oracle Cluster Registry. Oracle Cluster Registry OCR records cluster configuration information. If it fails, the entire clustered environment for Oracle 11g R2 RAC will be adversely affected. That means you won't be able to start up the cluster resources, because your OCR, which stores the information about those resources, that file itself is lost. Now in our case, where is our OCR? On a ASM disk group. What is the chance of we losing it? If one of my ASM disk fails and that disk was not protected by RAID, and I am not using a mirrored ASM disk group configuration, then my OCR is lost. So see, there's too much of a protection against OCR itself. First, it is on ASM. If ASM is mirrored, you need not worry, because OCR would also be mirrored in that case. If ASM is not mirrored, the disk group is not mirrored, at least if the LUNs are protected at a storage level with some RAID configuration, then also losing a disk on a storage will not necessarily cause a loss of your OCR. But assuming worst case scenario, you lost your OCR, then obviously the cluster will not start. So it will cause an outage. OCR is the central repository for CRS, that is the cluster ready services, which stores the metadata, configuration and state information for all cluster resources defined in the clusterware. It not just only stores the information, it also stores their state. That's why when we added during the cloning practical a database manually into OCR, although the instances were running, it says the instances are down. Then we use the command srvctl start database -d test. Then it went, and then it came to know they are already up and running. And since then onwards, it reflected the correct states. So that's what. It also stores resources metadata and their current state, like online, offline, on, off, up, running, down, whatever. The cluster registry is used to maintain application resources and their availability within the real application cluster environment. It also stores configuration information for CRS daemons and clusterware managed applications. What it stores essentially is node membership information, such as which nodes are part of clusterware, the active version. There is a software version and an active version. In either cases, it should show 11.20.20 in our case. So you can use the command So here I use the software version, which shows me the version of my Oracle software, and then I have checked the version that is embedded into my Oracle cluster registry. It stores the location of your voting disk. So OCR also stores the location of your voting disk. It stores what all server pools you have, by default only free and generic until you create server pools. Status of cluster resources such as RAC databases, listeners, instances, services, configuration of cluster resources such as their configuration also, not just the state, but also their configuration. That's why when you say srvctl config database -d test, how does it comes to know about these details? Because these details are registered in your Oracle cluster registry. It stores information about ASM instances, disk groups, CRS application resource profiles such as virtual IP addresses, service names, database service characteristics such as whether it's preferred, available nodes, the transparent application failover policy, the load balancing goals, information about your clusterware processes, information about interaction and management of third-party applications controlled by CRS. Remember, the third-party application resource I said was Apache web server that you want to fail over from one node to another. So you can register custom applications as well. details of network interfaces held by the cluster network, information about OCR backups also goes into OCR. So the whole thing goes as part of OCR. So not to mention, if it is lost, everything is lost. If you don't have a backup, you need to start salvaging the cluster. Each node, very important, how OCR is accessed. This is even more interesting. Each node in the cluster maintains a copy of OCR where? In memory. For better performance, so that every time I need to read or write something, I don't have to go and read it from the shared disk. Why it is costly, you will come to know once you understand who can read and write to OCR. So a copy of OCR is maintained into the memory to improve upon the performance of reading the data from OCR. And each node is responsible for updating the OCR as required. So each node is responsible to update the OCR. This could be misleading when I go down. The CRSD process is responsible for reading and writing to the OCR file as and when things keeps on changing. I added a new database. I need to update that database entry into the OCR. Who will do that? Actually CRSD. But which CRSD? That is still not discussed. Because there are node specific CRSD. So who would update? That is still a question. We'll discuss. The CRSD process is responsible for reading and writing to the OCR file as well as refreshing the local OCR cache maintained in memory and the caches on the other nodes in the cluster. Oracle uses a distributed shared cache architecture during cluster management to optimize queries against the cluster repository. Each node maintains a copy of OCR in memory. Oracle Clusterware uses a background process to access the OCR cache. Only one CRSD process designated as the master in the cluster performs any disk read or write activity. So although OCR is on a shared disk, that does not mean all processes at random can read and write to it. Only the CRSD process from the master node will be able to read and write. So it's a proxy read and proxy write. So it reads it for other CRSD daemons on other machines. It writes on the behalf of all other machines. What if the master node goes down? The clusterware will elect a new master. So now the CRSD process running on that new master will have a read-write access to the OCR. Once any new information is read by the master CRSD process, it performs a refresh of the local OCR cache and the OCR cache on other nodes in the cluster as well. Since the OCR cache is distributed across all nodes in the cluster, OCR clients, SRVCTL, CRSCTL, communicates directly with the local OCR process on the node to obtain the required information. Clients communicate via local CRSD process for any updates on the physical OCR binary file. So whenever you use any client utility like SRVCTL, CRSCTL, it does not go and reads that information afresh from OCR. They directly go and check OCR cache of your local machine, which is periodically refreshed. In 11G release 2, you can have up to 5 OCR copies. Now given the fact that this file is very important, obviously I can't afford to lose it. A small disk of around 3 to 500 MB is normally recommended for OCR. Even the complex configuration will not be more than 300 MB. But to be on a safer side and to avoid alerts, Oracle recommends it to be around 300 to 500 MB. The OCR config command cannot modify the OCR configuration information for that node that are shut down or for nodes on which the Oracle Clusterware itself is not running. So you should avoid shutting down the nodes while modifying the OCR using the OCR config command. If for any reason any of the nodes in the clusterware were down while you are modifying the OCR using that OCR config command, you will need to perform a repair on the stop node before you can bring it up online so that it can successfully join a cluster. Consider a case. I had alpha and beta. On beta, CRS is down. Originally, my OCR was on shared CFS or NFS location. I will call it as /shared/OCR/OCR.bin. Now while one node was down, I have migrated from alpha, you migrated the OCR from CFS NFS shared location to ASM disk group. Clear? So I have changed the location. Earlier my OCR was on a shared location. I changed it from shared location to ASM. So from CFS NFS location I changed it to ASM. But when I did these changes, beta was down. So beta will never come to know that my OCR in the meanwhile, while it was down, has migrated from the old location to the new location. That is what I have mentioned on this slide. The OCR command cannot modify OCR configuration information for those nodes which were down or for those nodes where the clusterware was not up and running. So if you should avoid shutting down nodes while you are doing the modifications to the OCR location. Well, for if some reason if those nodes were anyways down and you have anyways modified, now there is no reversal, you have to just perform the repair action on the beta node once it comes up and running. Otherwise it will never be able to go and read from the new location. The OCR config repair command changes the OCR configuration only on the node on which you run the command. Remember, OCR config repair command will only change it on the node which is where you are typing the command. So if in a 3-node cluster 2 nodes were down and my OCR was live migrated from X location to Y location, CFS NFS to ASM, those beta and gamma node were down. Then I came to beta, I said repair. Until I repair, cluster services won't be able to start because on beta my OCR is still pointing to the old location where it does not exist, which I have done migration from alpha node. So don't expect when you type the repair command on beta it will go and do the changes on gamma as well. You will have to go and type the same command on any other node, those which were down while you were doing the OCR migration. This is what it means here. Okay, some of the frequently used OCR commands. Add an OCR file to an ASM disk group called as data. Then you can say OCR config add plus data. This is to add a copy of OCR. If you want to move an existing OCR file to another location, you can say OCR config hyphen replace current location replacement location. So U01 APP Oracle OCR, I assume it was a CFS NFS directory. Now you want to move it from there to elsewhere. That is on ASM disk group name data. To remove an OCR location, obviously you can only do it when you have multiple copies of OCR. If you had only one copy of OCR and that is true you are trying to remove, Oracle will never allow you. So removing an OCR location, you can say OCR config hyphen delete plus data, which means delete the copy of OCR which is currently there on the disk group data. After successful execution, ensure you should still have another copy somewhere else. Otherwise the command itself will not work. To repair the OCR from a given node, you can say OCR config hyphen repair hyphen add the new location. The new location. So it will automatically start your OCR pointer file to that new location now. To list auto backups of OCR, you can say OCR config hyphen show backup auto. Remember, OCR is automatically and periodically backed up by Oracle because it's a very critical file. So if you want to see if there are any such auto backups that Oracle has performed, where they are, then you can use the command OCR config hyphen show backup auto. These are the automatic backups of your OCR. More on it will come later. Now when Oracle performs automatic backup of your OCR, it maintains 3 last recent daily backups. 2 last, sorry, mistake. It maintains last 3 4 hourly backups, last 2 daily backups, last 2 weekly backups. So this is the by default retention policy of backup. I told you OCR backup is taken by whom? Oracle, automatically. So if it keeps on taking backup, what would happen one day? Your entire disk will be full by OCR backups only. So Oracle also automatically applies a retention policy. The retention policy is every 4 hours it performs a backup, and that means in a given day how many backups will be there? 6. That doesn't mean it maintains all 6 copies. Last 3 recent 4 hourly backup copies will be maintained. Anything older than that will be purged. Last 2 daily backups will be retained, others will be purged. Last 2 weekly backups will be retained, older than that will be purged. Okay. Do I have all of them as of now? I have backup 1, backup 2, backup 3. Then I have daily and weekly. Probably I never had my cluster up and running for that long to maintain 2 daily backups and 2 weekly backups. So this is by default the retention policy of OCR backups. People say, can I influence it? Answer is no. It's hard coded into the program code. People say, no, I want to maintain, instead of 4 hourly, I want to maintain every hour. Then write a cron job to perform a manual backup of your OCR every 1 hour. So to perform a manual backup, and I want to see if there is any manual backup. See what it says? No manual backup. So you can type a command OCR config show backup without auto, without manual. It will show both. So it says these are auto and I couldn't find any manual backup. Clear? To perform a manual backup of it, you can type the command OCR config -manual backup. So I am logging in as root. So I said OCR config -manual backup. Now it has taken a backup. Now one important and interesting thing about this one is whether it's an auto backup or a manual backup, irrespective of the node where you are typing it, the backup itself may go in any of the nodes. On which node I typed the command manual backup? But it stored the backup, see where? It stored the backup onto beta. Okay, people say, can I control this? Answer is no. That's what I recommend you then. Well, if you can't control from which node the backups are happening, at least you can control the backup location. So let the backup location be something which is visible both to alpha and beta, meaning a shared file system or a network mounted file system. You can change the backup location by typing the command OCR config -backuploc, backup LOC, and change it to somewhere else. By default, the backups will go in grid home C data cluster name directory. Grid home C data cluster name. This would be the location for your backups. If you don't like this backup location, because I told you grid home is not shared in our case, means either the backups are available on alpha and on beta. So in a worst case, let's say all my backups were on beta and beta itself has experienced a fatal failure, hardware fault, and my OLR is lost. How can I restore now? My OCR is lost. How can I restore? Nothing. Because it went to a disk location which was very private to beta, and now I lost it. So change the location. So I can always say OCR config, and you can use backup location and specify alternate directory location. I am assuming this alternate directory location is accessible from both the nodes. People say, can I store it on ACFS? ACFS is accessible from alpha and beta. Can I store a OCR backup on ACFS, which is a shared cluster file system mount on alpha and beta, if I have created ACFS? Answer is never do that. Never do it. Because to access ACFS, what I need to start? ASM. And if my OCR is lost, can I start ASM? Can I mount ACFS? So don't store it on ACFS. Store it on either NFS or in some location which is accessible to all the nodes in the cluster. To take a logical backup, you can say OCR config -export followed by export file name. You can also change the backup location. To locate your OCR backup, you can say, this is an important topic, how to restore if my OCR itself is lost. So first, know where the backup is. So I'm assuming you already knew where your backup was. Well, I had always documented, assuming that I knew where my backups are. Once you know where your physical manual backups are, then stop the clusterware stack on all the nodes. So on all the machines, part of your cluster, stop the clusterware stack. Say CRS-CTL stop CRS. Now to stop the CRS, what I need? OCR. So will I be able to stop it if my OCR itself is missing? Well, if it doesn't stops, then use a force option. CRS-CTL stop CRS-F. It is like a force stop if the previous one fails due to corruption or due to a missing OCR. Once done, on any one node, I am assuming alpha, start the CRS on one node in exclusive mode by saying CRS-CTL start CRS-EXCL. Exclusive mode means no other system can now start the clusterware stack. Anyways, they won't be able to, because some processes will start. Not everything that is possible on a clusterware will start, because the information was in OCR and OCR itself is missing. So start it only on one node saying exclusive. Now once the clusterware is started in exclusive mode, if CRSD is still running, then stop it. So CRS-CTL stop resource ora.crsd-init. So it will stop the CRSD daemon. I am asking you to stop CRSD daemon. Who reads and writes to OCR? CRSD. That's why we are asking categorically only one daemon to be down by saying CRS-CTL stop resource ora.crsd-init. Restore the OCR from its physical backup taken earlier by saying OCR config -restore path to the backup file, provided you know from command number 1 where your backup is. Once it is restored, type the command OCR check to check the logical corruption and integrity checks. Everything is okay, then stop the clusterware which you have started on the current node in exclusive mode by saying CRS-CTL stop CRS. If it doesn't work for some reason, then force stop it. Once it is stopped, then go on all nodes and start it regularly by saying CRS-CTL start CRS. At the end, you may want to be confident about that it has been restored correctly. Run cluster verification utility for your own satisfaction. So say CLU-VFI comp OCR -n all. -n all means all nodes. Verbose. So print me all the messages. Next one is cluster health monitor tool. I told you earlier in 11.20.20 CHM has been introduced. CHM collects operating system statistics, matrices such as memory, swap space, processes, IO usage and network related data. The CHM collects information in real time. This is more important, and usually at a gap of 1 second. Every second it collects these statistics. CHM collects operating system statistics using OS API to gain performance and reduce the CPU usage overhead. CHM collects as much of system matrices and data as feasible that is restricted by the acceptable level of resource consumption by the tool. Meaning, what level of details to be captured can be configured, called as log level. So you can configure at what details you want to capture. By default, it is set at a normal level. So you can do a more verbose capturing, but assume If I say capture detailed logs, then what will happen? There will be an extra overhead on your machine. CHM provides system metrics and data for troubleshooting many different types of problems, and one most commonly seen problem in RAC is a random node reboot. So one of the node keeps on rebooting one of the either nodes. Instance eviction, server hang, severe performance degradation, and any other problem that can be reportedly seen through system metrics and data. By monitoring the data constantly, users can use CHM to detect potential problem areas such as CPU load, memory, excessive memory usage, spinning of processes, that is runaway processes, before the problem causes an unwanted outage on the system. It is integrated part of 11.20.20 grid infrastructure. So if you use 11G release 2, 11.20.10, CHM is not part of it. It came in via 11.20.20. Aura.crf is the cluster health monitor resource name that is managed via OHASD. So you can say CRS-CTL status resource -t in it, and you will see one such resource is Aura.crf. It will show you the cluster health check monitor status. So I am saying Aura.crf is running on alpha. People say, what if I am running a non-RAC environment and I still want your utility? You say that this utility collects all the statistics and I would like to use it. Yes, there is a standalone version of CHM also available. In that case, don't go on the name. The people, they may have a complaint against. You said it's for single node. Then why is not the tool name as non-RAC health monitor? So don't go on the name. It is also available as a standalone utility. If your version is not 11.20.20 or if you want to install it in a non-RAC environment. If the CHM is installed as part of 11.2, then the location of the tool name is the cluster health monitor, CHM. The older name for that tool was IPD/OS, was the older name. But if I want to see what is the actual executable file, the executable file is oclumon, and it comes from grid home bin directory. I can type -h to show the help, or more appropriately help. Currently supported verbs are these many only. I don't know if it is expecting as a hyphen. Well, I don't know. So oclumon help, this is how it works, it says. But if you want to see each of the meaning of those verbs, which is show trail, show objects, dump node view, manage versions, debug, quit, exit, and help, you can further type it with a -h. So I said it shows the help about show trail or show objects for that matter. To produce the output of all the data that is collected by your cluster health monitor, you can run the command grid home bin diag collection --collect chmos. That CHM is nothing but cluster health monitor OS for OS. There's another way. Now assume how frequently it is collecting the statistics at an interval of 1 second. For which nodes? All the nodes. Who is doing this? OSysmon-D, one of the daemons that we saw in OHSD. OSysmon-D daemon is collecting. Who is writing and where he is writing? OLogger-D daemon is receiving those updates from OSysmon-D and it's writing to the CHM database repository, which is a Berkeley database. Now assume for all the nodes, how big would be that data? Huge. If it collects for every 1 second. By default, it only retains data for last 24 hours. It does not store it forever. But for normally we tell that CHM would require a disk space of 1 GB and a daily log generation will be of 0.5 GB. So daily कितने के statistic generate करेगा वो 0.5 500 MB. Now if I say go through the 500 MB or 1 GB of the data and produce me a more meaningful report, DAC collection.pl collect CHMOS, no restrictions, means whatever data is available in your Berkeley database, go through, analyze and produce me a more meaningful information. Who would read it? Every second. Who would read that data? No one. Well, if you want to produce a crisp report between a specific timeline, then you can pass on add-on options. DAC collection.pl collect CRS home, whatever, CHMOS, incident time, and followed by incident duration. So I knew the problems occurred at 1 AM today and they were persistent for 5 hours on and off. So I can say incident time is today at 1 PM and for the incident duration of 5 hours. So it will only scan the detailed metrics collected between this time frame. So starting at 1 PM for next 5 hours. So you can use, so filter that output by saying incident time. Remember the incident time has to be mentioned in a strange date. mm/dd/YYYYHH:/MN:/SS. And then the incident duration, which is hours:/minutes. For how long? Starting from that time till how long? Those logs must be analyzed to produce a more crisp and a meaningful output of cluster health monitor. You can also use oclumon command, dump node view all nodes -v -last 11:59:59. What does this mean? It simply means show me the monitor data collected for all the nodes for last 12 hours. So from now, last 12 hours, you scan the data and then produce me a more meaningful output. One could have also used clumon dump node view all nodes -v. Now here there is a small variation. -s is the start time and -e is the end time. So I am not saying from now past 12 hours. So I am directly saying starting from this time to ending this time, scan all the operating system matrices collected by CHM and then produce me a readable output. You can also use the command grid home bin DAC collection.pl -h to obtain further help, or oclumon -h to obtain further help on how to use it for reporting purpose. CHM is recommended over OS Watcher. Now those who are DBS from 9i 10G versions, prior to CHM coming in picture, we used to have an utility called as OS Watcher. It's available for free download on Metalink. So what we used to do, we used to download that utility and schedule it as a cron job, or it has itself a scheduling facility called as OSW. And we need to define the scheduling frequency and the retention period. So every scheduling interval, it will go and collect all the operating system statistics such as processes, top processes, all the processes, top running processes, real memory usage, virtual memory usage, network statistics such as netstat for interconnects, and all other like CPU usage or general statistics that we capture otherwise. The only problem with OS Watcher is it's a user scheduled program. That means when my CPU is 100% busy, OS Watcher does not get any special treatment. It says you are on wait. So this was the time where actually my node rebooted. CPU was 100% used. The OCSSD daemon on the other node says hi. This wanted to say hello, but CPU was 100% busy. By the time CPU usage dropped down and it came and said hello back to it, the other node says stonit, shoot the other node in the head, heartbeat missed. Now how could you expect OS Watcher to collect the statistics even if I schedule it at an interval of 1 second? because it's a user daemon. It's a user process. If my OCSSD daemon, which runs with a elevated priority, didn't get a chance to schedule on a CPU, OS watcher is a distant dream. So my OS watcher data was missing. Then I opened a ticket with Oracle support. They said, upload us the OS watcher log. I uploaded them. They said, for the exact period when the node rebooted, there are no statistics. How could there be statistics? CPU was 100% busy. That's why the heartbeat was missed. And how do you expect the similar, even a non-privileged program with a lesser priority and a nice value to collect and show us the statistics? That's why over OSW, I recommend you to use CHM, because CHM runs with a elevated priority. It directly makes use of the OS level APIs. So even if there is a CPU crunch, your statistics would still be collected. CHM is recommended over OS watcher as it runs with a RT priority, real time, as against OS watcher which runs with the user priority. So for that exact split second moment, if you wanted to obtain statistics, then a better alternative to OS watcher is CHM. CHM can add up to 5% overhead, but only on one CPU core. It does not as a, so don't think like my machine has 64 CPUs. So 64 CPUs ka 5% is how much? That means I am spending one CPU only for collecting the statistics. No, I am saying it's a uni-threaded process. It consumes only one CPU core ka 5% power, which is affordable. CHM takes 1 GB disk space by default on all nodes in the cluster. The approximate amount of data collected is 0.5 GB per node per day. The size of the repository can increase to collect and save data up to 3 days, and this will increase the disk usage appropriately. So per node per day, what is the expected overhead generation? 500 MB, 512 MB roughly. If there are 10 nodes, 5 GB per day. Where the data is stored? In a CHM database repository, which is a Berkeley DB. That means you are sending 5 GB of data over the network from the OSysmon of that node to the OLogger of the logging node. And then that node, OLogger will write that data into the Berkeley database. So if you generate a report of 5 GB, it will take 2 days. It will say come after 2 days. I will show you what happened in those. So that's why you always run that report with a restricted start and end time, only for the period where you encountered the problem. At the max, what one can do, I said by default how many days worth data is saved? 24 hours. You can increase it at the max up to 3 days. And the time is always mentioned in seconds. So you can say OCLU manage, get, repository size. Let's do this. So I am saying OCLU manage hyphen get hyphen repository size typo OCLU mon. So it shows me repository size in what? It shows the repository size in seconds. I don't know what it translates to. Let's calculate. These many seconds divided by 60 seconds in a minute, these many minutes divided by 60 such minutes in an hour. So this much. Clear? So this is my current repository size. If you want to change the repository size, you can say OCLU manage hyphen repos resize number of seconds which is less than 2592200. I don't know what is the relationship. Let's use a calculator. In 1 hour, there are 3600 seconds. In 24 hours, it comes to 86400. For 3 such days, it becomes 259200. That's what I said. At the max, how many days old data can be retained in that Berkeley repository DB, CHMDB for last 3 days, not more than this. So you have to mention a value in seconds for resizing that repository, which is 259200 seconds or less. Then I talked about this thing earlier also, the logger service and the sysmon. So I will not talk about this thing anymore now. So on each node there is OSysMonD. Responsibility of OSysMonD is to collect that node's OS matrices. And then once collected, do what? Send it to O-loggerD. O-loggerD will only run on 2 nodes, irrespective of the number of nodes in the cluster. And whatever are the statistics collected and captured from the other by O-loggerD from other OSysMonD processes, it will record it into the Berkeley DB. That Berkeley DB is a collection of binary files with the extension BDB and log, which are nothing but the redo logs for Berkeley DB. And those are recorded in this format. Okay, what is the purpose? To record it in a more meaningful and a binary compressed format so that it can produce a more meaningful output by OCLU-mon process or command. Then OCLU-mon is a command line tool. Use OCLU-mon command line tool to query the CHM repository to display node-specific matrices for a specified time period. You can use CRSCTL stop resource ora.crf-init if everything is working fine. There is no point collecting statistics. If you don't like that CHM to continue collecting statistics because it adds 5% per CPU, or not per, 5% on one CPU core, the burden, and you certainly do not like 512 MB of data collected for every node and transport over the network, in that case you can disable, stop the cluster health monitor. Do not do it on unstable cluster. If your cluster is not stable, you are experiencing node hang, node reboot, performance degradation, let it run. So that when you open a ticket, it becomes easy for you to convince Oracle that indeed there was a problem. But your cluster is stable, it never rebooted, then there's no point running cluster health monitor. I wonder how many such clusters would be there in the world, those which never reboot. At least the ones that I work on, they reboot every few days. So that keeps me awake. Next is about diagnostics. Resolving node reboot issues at times could be really painful. The service request moves between Oracle support and DBS for service for request and responses. You open a ticket, Oracle says give me alert log. You give alert log, then he says give me trace file. You give trace file, he says give me the commands output. You give the command output, he says give me your name also. You give your name, he says tell me your salary also. So it keeps on moving. You won't believe, for 10G release 1, I opened a ticket for node reboot which lasted only for 7 months. So for 7 months he used to ask questions, I used to provide answers. And one day I was frustrated, I said close it, the customer has already decided not to go on RAC. So to reduce, by the way, this never, node reboot is not very frequent until everything is proper. I have seen some stable clusters, especially this combination. Solaris, Veritas cluster, and on top of that Oracle RAC. Such a stable cluster that they even push the power off button, still the machine is running. It rarely goes down, to an extent that it was running for more than a year without any problem, without anything. I often see these issues because of heartbeat misses. Now it could be because of anything. Now it becomes a blame game. If it's AIX, IBM says Oracle rebooted it. Ask them why it rebooted. You go to Oracle, they say your operating system scheduler has a flaw. My OCSSD process runs with the top priority. There was a CPU bottleneck. I said, who told you? OS Watcher. Now CHM. Cluster monitor health check was showing that CPU was 100% occupied. You were doing a bulk activity. My OCSSD said, I want to say hello to the other node. Your CPU said, wait. The other node lost the patient. I killed you. Check with AIX why it never scheduled. You go to AIX, they said there is no proof. So it becomes a wild goose chase. You keep on chasing different people. And its node in the meanwhile keeps on rebooting. So it becomes a wild goose chase. So what they have done, now they have given a beautiful utility. So to reduce the dialogue between Oracle support and the supporting DBA, you can run diag collection. One beauty of this product is it collects cluster diagnostic logs, OCR data, Oracle's log and trace file. If there are any core dumps, it also bundles those core dumps. It also bundles the OSK configuration as one couple of zip files, tar.g zip file. Upload them, they will not ask you anything. So they will directly then blame it. It's OS. So at least they will, if you want to blame the OS, blame it on day one itself. Why to ask for 30 different log files and then blame on 31st day? It's the OS which is the culprit. So this utility, at least, it may not solve the problem, but it at least reduces the frustration of that job. That frustration is every now and then they will keep on asking you the new log. So grid home bin diag collection.sh -adr tmp collect before time so and so or after time so and so, which is a timestamp. So it will collect all the statistics for that limited period. If you simply run diag collection, it will collect all the statistics, all of them. Starting from 11/2040, very recently, Oracle instead installs a better diagnostic collection utility called as Trace File Analyzer Collector, TFA. But it's only available for whom? For 11/2040 and onwards. People say, I want to, if it is so better, then I also want to use it. Anyways, it's available as a separate download as well. So you can download it as a separate utility from Metalink, which is a diagnostic collection utility to simplify diagnostic data collection with respect to Oracle clusterware, grid infrastructure, RAC, and single database systems. So it collects even more with verbosity, with lesser overhead, diagnostic data. So assuming that you have installed this utility, how can you collect? TFA CTL diag collect. Those who want to know more about TFA CTL or TFA collector, you can visit the Metalink node 1513912.1. So there's the tool is also available, and the documentation is also available. There's also a video available how to use it. By default, your current version 11.2020 comes only with cluster health monitor and the diag tool. If you are happy with it, well ahead, go ahead, submit them the logs. If not, you want the advanced collector, then use TFA. And that's it for this session. So this is what I wanted to do on the diagnostic part. Remember, I deliberately did this session because there's a very few documents available on whatever I covered in the PPT. So I wanted to do it for everyone, and I also wanted to have a video recording done of this one. So thanks for joining into this session.